All right, so that should be going. Yeah, so welcome to the info session. As I said, I'm Anna Eglund. I'm the graduate advisor for CEE in-person programs, and I have with me Professor Jeff Berman, who's one of the structures faculty. He's going to give a brief presentation on sort of overview to the graduate programs in structures. And then we'll have some time for questions at the end. So definitely think of your questions as you're going. And as I said, you can either unmute and ask your question. You can use the raise your hand function maybe first, or feel free to type those in the chat and I can read them out at the end. All right, so I will pass it over to Professor Berman and we can get started.
Great, thank you, Anna. So let's see, I'm gonna try to share here. Okay, how's that? Can everyone see? I guess, Anna, can you see the slides?
I think it's a success.
Okay, excellent, great. Okay, I'm going to talk about the structural engineering and mechanics graduate degree programs that we have. First, before we get going, I'll introduce the structural engineering faculty here at the University of Washington. Just give you like a one-sentence introduction of their research areas and kind of what they do, and some of the classes that they teach, and then we'll get into the program. So I'm Jeff Berman. I do research on steel structures, on earthquake engineering, on structural control, and a few things that aren't listed there is mass timber research, and I do a lot of both experiments in the laboratory and numerical modeling. And also I am the operations director for our NERI facility, which is the RAPID facility that does post-disaster reconnaissance work. Paulo Calvi is he's a specialist in reinforced concrete structures, also in seismic isolation, and lots of other problems in earthquake engineering. He's on sabbatical this year, but will be around next year. And when he's here, he usually teaches graduate courses like structural dynamics and earthquake engineering, as well as some different courses at the undergraduate level. Mark Eberhard is a researcher in reinforced concrete structures, and in particular, a lot of experience with bridges and bridge engineering. Also, a lot of earthquake engineering background and work that he does, and kind of similar to me, does a lot of work in the laboratory and also behind the computer. Dawn Lehman is a researcher both in reinforced concrete and steel structures. She also does a lot of earthquake engineering and performance-based design. She does a lot of work in the laboratory, definitely you can find her research team active in the laboratory. Laura Lowe's does a lot of numerical modeling. She also does a lot of applications in earthquake engineering, but a lot less in the laboratory and much more with constitutive modeling, and she's had a lot of research experience with reinforced concrete shear walls and a lot of the numerical modeling complexities for those. Peter Mackenzie Helnwyn is he does a lot of really advanced finite element analysis, structural stability. He applies his numerical modeling expertise in many, many different applications. He's had applications looking at rubber and timber and all kinds of different things. He writes a lot of finite element code for custom problems and things like that. Mike Motley is a researcher in fluid structure interaction. He does a lot of work related to tsunami impacts on structures and kind of the interaction between the fluids and the structures and how they generate structural loads. He also does a lot of work with the design and kind of stresses deformations and design of turbine blades. both for marine applications and for air applications. And then Travis Thonstad he does a lot of a little bit more on the materials side of reinforced concrete design. He has had a lot of experience with kind of high performance reinforced concrete materials. Usually the applications are earthquake engineering, but also structural collapse under gravity loads and other things like that. And he's done a lot of work in pre-stressed concrete in particular. John Stanton is another one of our bridge engineers. He's kind of world-renowned expert in pre-stressed concrete structures. He's also done a lot of work in seismic isolation and a lot of applications in bridges. And then Richard Wiebe does nonlinear structural dynamics and stability analysis and problems in kind of experimental mechanics. Some of his work is supported in for Boeing research projects. He does a lot of aeronautical type of applications with his structural engineering research. So a little bit about where we are within the overall department. Sorry, some of these figures are not great. I'm presenting this out of Google Slides instead of PowerPoint, and for some reason, some of the photos are a little blurry, but so we are the Structural Engineering and Mechanics group. We are within the Department of Civil Engineering, Civil and Environmental Engineering at the University of Washington. The other kind of groups that are represented within Civil and Environmental Engineering are Environmental Engineering, Construction Engineering, Hydrology and Hydrodynamics, Transportation, and Geotechnical Engineering. And when you study structural engineering at the University of Washington, you're definitely able to take courses in these different areas, should you so choose. Also, we are a department within a larger College of Engineering at the University of Washington, and there are all these different departments within that college, including aeronautics and astronautics, mechanical engineering, material science engineering, and I'm pointing those out because those are departments that we often work with or our students take classes in, as I'll talk about. And also industrials and systems engineering should be included there. Okay, so what I'm going to go through is our degree programs that we offer. I'll talk real briefly about the courses themselves, and then maybe we'll hold questions till the end since we are recording this, and so you can ignore what's in the parentheses there. We'll answer questions at the end. Okay, so our master's degree programs are really, we have two different master's degree programs. The degree that you get at the end of both of these programs is the same. It is a Master of Science in Civil Engineering. And the differences in these two programs are really kind of what you do with some of the credits and some other things. So for both the programs, it requires 42 credits. The two programs are the Professional Master's Program and the Research or Thesis-based Master's Program. And the intention with the Professional Master's Program is really to take those 42 credits of coursework. And there's a couple different ways that we can slice that up, but for the most part, it's 42 credits of coursework. For the research, we do allow, I should note, we do allow you to break off 3 of those credits to do various one-credit seminars that you may find within the department or around the university. And then on the for the thesis-based program, it is still 42 credits, but 9 of those credits are thesis. Thesis. What happens with the thesis-based program is typically a thesis student is working with a faculty member on a research project. And that research project becomes what is in their thesis. These research projects are usually funded by grants that the faculty member pursues. Those could be coming from places like the National Science Foundation or the American Institute of Steel Construction, or other kind of national state agencies, national and state agencies that fund research, and they have questions to answer. So we write proposals to answer those questions, to do that research, and then we work with our graduate students to actually get that done. That is a combination of both PhD students, which I'll talk about after, and thesis-based master students. Along with those grants come funding to support the research-based master students. So for a thesis student, you will typically have a tuition waiver, meaning you pay no tuition, and you will get a stipend. And that stipend generally covers cost of living. So it's generally enough. I wouldn't say it's an extravagant lifestyle, but it's generally enough to cover the cost of living and feeding yourself and everything else. Those spots, the research-based spots, are competitive. We have each year we may support, I would say on average, around 8 or so new research-based master students who are coming into the program. For those 8 spots, we'll have maybe as many as 50 applicants. And so it is quite a bit more competitive to get into the research-based program. For the professional master's program, that is just 42 credits of classes. It is still a competitive program to get into, but typically if you're coming from a U.S. institution, you have a Bachelor's of Science in Civil Engineering. Typically with something like a 3.3, 3.4, you're going to be granted admission. For University of Washington students who did their bachelor's degree in our department and got a Bachelor's of Civil Engineering, we pretty much automatically accept everyone with a 3.2 GPA and above into the professional master's program. So that's a little bit about how those two programs kind of differ in terms of both the coursework, essentially 42 credits of classes in the professional master's program versus 33 credits of classes and 9 credits of thesis in the thesis program. And most of the time, those thesis students are funded and not paying tuition, but it is, again, a more competitive program. It is possible to switch from one to the other. If you are admitted and come to join the professional master's program and some spots open up on research projects and you're interested in doing that, talk to the faculty, and it is possible to switch. Again, there's a limited number of spots, and that is kind of, they still are competitive, but we have had students certainly switch from professional master's program into the research thesis program. And we've had students who kind of start out in the thesis program, but maybe decide either that they weren't able to find a project that they're really interested in and don't want to spend 2 years of work working on that particular topic, or for some other reason, something happens in life and they want to switch to the master's program, the professional master's program, and just finish out with coursework, and that is possible as well. We also have a PhD program, and we'll accept applicants into the PhD program. These are competitive spots. You do not need to have a master's degree to apply to the PhD program, but you have to get one along the way. And that could be either with a thesis or with coursework. And I've had PhD students kind of do both of those things. The PhD requirements, there's several more complicated PhD requirements, including a qualifying exam that happens usually within the first year of study once you're here. There's additional coursework. There's a general exam, which is essentially the proposal for your research and the dissertation, and then a final presentation of your research. And usually a PhD program, including a master's, is about a 5-year haul to get that done. I'm happy to talk with those who are interested in the PhD program in more detail. Afterwards, this will be the one slide that I have about the PhD program. Going back to the master's programs, the courses that you can take for both the research based track on the left-hand side here and the professional master's program, they are the same, the courses that are available. And I'll kind of walk through some of the degree requirements here just to kind of highlight what it is you would do for your time here in the master's program. We have 3 required classes for all of our master's students. That is a class in structural mechanics, CESG 501, a class in structural dynamics, CESG 502, and a class on finite elements, CESG 504. Those make up what we call the required core. Those 12 credits, each of them being a 4-credit class, make up what we call the required core. And everybody has to take that. And then after that, there are 21 remaining credits for thesis students and 30 remaining credits for professional master's program students. And those classes can be fulfilled in a number of different ways. We require, for both programs, 12 additional credits, which is usually, most of the other courses are 3-credit classes. So that's about 4 additional courses that are required from the list of 500-level structural engineering classes. And those are listed below. They include engineering computing, nonlinear analysis, structural stability, materials modeling, structural reliability and design, advanced reinforced concrete, pre-stressed concrete, advanced structural systems, steel, a series of earthquake engineering classes, wind design, bridge engineering, elasticity, and some other kind of more advanced continuum mechanics classes that are listed over on the right-hand side under suggested electives. So these classes that are listed here all count toward those 12 additional credits, and we don't tell you which ones you should take. Instead, we pair you with a faculty advisor, and you tell them about your interests in structural engineering and what you want to do, and we kind of work together to come up with your plan of study. And then the remaining credits out of that, which would be 9 credits for thesis students or 18 credits for professional master's program students, can be filled with any 500-level structural or geotechnical engineering course, any CEE, COE, or AMATH courses that are on the approved electives list that is down below. You may take 1 course from architecture or construction management that is also listed on an elective sheet that I'll show in some slides on the next slides, and or up to 3 credits of CE seminar. And we will take, but we have to prior approval. We will take 1 credit of seminar for seminars that happen in out of other departments, as long as they're relevant and kind of consistent with your plan. There is some flexibility in all of this. We make the rules, and we are able to modify the rules as we go along, but you must have approval from your faculty advisor for any modifications. So we really do want people talking to their advisor to really make this program work for their overall career goals. And then just handy down here are some departments with various electives that are out there. And then for as far as like minimums, how good do you have to do in all these courses? You need a 2.7 minimum grade in each course for it to count. Your cumulative GPA in all the CESG, the 500 level CESG courses needs to be 3.0 cumulative, and you need to keep a 3.0 cumulative overall. We will accept up to 6 credits of transfer credits, with the really, really important caveat that those 6 credits cannot have been used to fulfill any undergraduate requirements for completing your undergraduate degree at your undergraduate degree granting university. They have to be above and beyond what was necessary for your undergraduate degree. Okay, and now going through some of these electives that are available, yeah, going through some of these electives that are available. Around first, the civil engineering department, the geotechnical engineering courses are great. They are listed under the same CESG prefix as the structural engineering courses, but they are in the 550s and 560s as far as their numbers go. And I'm listing a couple here that are particularly good: advanced foundations and geotechnical earthquake engineering. They're particularly solid classes that pair well with our structural engineering course offerings. And then a class, this is also within the civil engineering department. It is in CESI, which is the construction and infrastructure group. They have a class 588 that is energy and the environment that's really good, that a lot of our students take as well. If it helps you understand, maybe do some calculations for lead and things like that. And then here's a big list of classes that are available that we would accept as electives. Again, these are classes that would fulfill this remaining 9 or 18 credits, 9 for thesis and 18 for professional master's folks. And you see it's an extensive list. It is not comprehensive, though. I would say each department does change course offerings, and so what I'm listing here may not be what is offered next year. There may be new classes and maybe some of these are not offered. But you see a bunch of good courses in aeronautics and in mechanical engineering and material science engineering, and then a whole bunch of really good AMath classes as well. The AMath classes can be a little bit more complicated to fit in to the schedule, because there are a lot of 5 credit classes in AMath. So that can be a little bit hard to kind of balance things out. But if you pair it with 1 credit of seminar, then it gets to 6, and the math works a little easier. And then out of the College of the Built Environment, the list of classes that we absolutely will accept include these architecture courses and these construction management courses. And then if you want to take courses that are outside this list, we would need a faculty advisor to approve that. And if you want to take more than 1 course from this list, that would also need approval by a faculty advisor, that it's consistent with your plan. And the reason for that is that these courses are a little bit less technical than the structural engineering courses, a little bit less on the math and physics and And so we want to make sure it is aligning with your structural engineering career goals and for getting a master's in our program. So for the courses within the structural engineering program, what is offered this year, this will differ a little bit from what is offered next year. Kind of things move around each year just a little bit. But we have not set next year's schedule in stone yet, so that's why it's not here. Instead, we'll use this year's as a proxy for what will be offered next year. So you see in the fall, we have 2 of those required classes, structural mechanics and structural dynamics, and then several electives. And the reason there's so many electives here is that often our professional master's students take 4 quarters to finish, and they're often looking for additional electives for that 4th quarter, that wraparound quarter in autumn of what would be their 2nd year. And so we have a few additional offerings in the autumn. In the winter, there is 1 of those required classes and then a series of those electives, including materials modeling, pre-stressed concrete, and advanced steel design. And then in spring, it is just electives. And then we have been offering, I think it's going to stay in the summer, but I'm not 100% sure about that. We have been offering one of our earthquake engineering courses that kind of sits between Earthquake Engineering 1, 526, and Earthquake Engineering 2, which would be 527, this advanced earthquake engineering topics. This one, the 599, sits kind of in between those two. Topically, there's very little overlap between these 3 classes. And we've been offering that in the summer. If it is not offered in the summer, what's going to happen is these earthquake engineering classes will all shift back a little bit. So we'll have Earthquake Engineering 1 being offered in the winter and this 599 being offered in the spring. Okay, so how long does this take? Usually our professional master's program students finish in 4 quarters. I would say most finish in 4 quarters. Some finish in 3 quarters, but it is quite challenging. To do 3 quarters, you've got 14 credits per quarter, kind of minimum. It doesn't really work out that way with the 4 credit classes. It's kind of 2 16s and 10. It is really tough to do this. Very challenging. It is easier if you can bring those 6 transfer credits, because that does cut down on the number of courses that you have to take by 2, but it is really challenging to get that done in 1 year, in 3 academic quarters. And we are on the quarter system for those of you who are not familiar with the quarter system. So autumn quarter runs from the end of September through right before the holidays, kind of mid-December. And then winter quarter starts right at the beginning of January and goes till end of March. And then spring quarter goes from kind of April through mid-June. So like I have listed here, 4 quarters is the more common approach. And then usually what students often do is they may find an internship to work in that summer that is between kind of spring and fall, and then come back and take the 2 or 3 classes they need to finish up their master's degree and complete that. And the internship is a great way to kind of get a foot in with a company and kind of get a good line on a job. And often what happens is they come back for fall and then they go to work for the company that they worked for that summer. Companies are very interested in having interns who have had 1 year of graduate courses. They're, I would say, highly valued interns. And so there are a lot of opportunities in Seattle to work for really good structural engineering firms in that summer in between. And then with the summer class, with that earthquake engineering class, kind of earthquake engineering, let's call it 1.5, that sits between earthquake engineering 1 and 2. That class has been offered over the summer, and some students have been able to kind of work hard, but still finish with the fourth quarter being that summer. Many students also take 5 quarters to finish because they want to make sure they're giving themselves enough time and doing really well. More than 5 quarters is also common for students who are kind of going through the professional master's program part-time, because they maybe are working 20 hours a week or something like that as well. And like I said, many students work internships in the summer and often are not taking any classes in the summer. So for those who are doing, who are interested in the thesis program, really, let me skip down to this bullet down here first. Most students take at least 7 quarters to finish with a thesis. You can kind of think about it as a fall. So you start your master's program in the fall, you'll do a full academic year, and then you'll probably do most of the next academic year as well. Often students are finishing up either at the end of winter quarter or at the end of spring quarter to get their thesis wrapped up. If you are interested in applying for either the thesis master's program or the PhD program, I have the application dates on the next slide. But what happens is we collect all of those applications, we look through all the applications, we have to determine from our grant funding how many students, how many funded students we're going to bring in. Then we often have a visitation where we invite students to come to campus and kind of learn about the program and the projects. Then we will make an offer to thesis students, usually by around March 8th, making an offer to students to come and have this funded position where they're going to work on a thesis research project with us. And then this date of April 15th is agreed upon by all the universities that kind of do research throughout the US, where we require responses for our offers by April 15th. So you have to respond to our offer by April 15th. Offers for the structures program thesis students typically come from the structural engineering faculty as a whole, rather than an individual faculty member. And usually we then align students, funded students, with their thesis projects sometime during the fall quarter. And that research is really kind of initiated beginning in the winter or the spring. And what typically happens for the incoming master students is that they may TA, be a teaching assistant for the first quarter or even the first 2 quarters that they're here, instead of kind of immediately starting on the research project. Like I said, most students require at least 7 quarters to finish with most students require 7 quarters to finish with a thesis. That would be 4 quarters from that first year, 3 quarters from the next year, finishing up in the spring. When we do make an offer for someone to do a thesis with us or to come to our PhD program, that offer is going to include tuition and a stipend. These are, like I said, tied to our grant funding. We talked about, I kind of listed the courses previously. In the interest of time, I have a bunch of detailed slides on what's in the actual courses. I'm going to skip through those because they're pretty much the same. There's not that much difference between pre-stressed concrete class at the University of Washington than pre-stressed concrete design class at Purdue University, other than the fact that you get to take it with John Stanton. So I'll skip through those pretty quickly, and instead kind of finish up with why you might want to choose the University of Washington for your master's degree in structural engineering. First, that is that we have active and diverse research program. And with that active and diverse research program, we have recruited and retained really, really good faculty. Faculty kind of are motivated by research opportunities and the ability to work with really good graduate students. And we have that, and we have a really great faculty because of that. It's not just the research, but also we have excellent faculty who really take teaching seriously. We have 2 UW Distinguished Teaching Award winners within the structural engineering faculty, and this is a University of Washington-wide teaching award. It is extremely competitive. They give 1 of these out per year, and we have 2 awardees in our structural engineering program. We are well connected with local industry. We have a structural engineering focused career fair that is run by the Structural Engineers Association of Washington that happens in January every year. We have a series of lunch and learn seminars that are again run by the Younger Members Forum of the Structural Engineers Association of Washington. And there's just many opportunities to engage with practice here. I would say structural engineering in the Pacific Northwest is very challenging. It's a high seismic zone. It attracts people who want to do really challenging structural engineering, and I would kind of stand our practitioners up against practitioners in any other region of the country. I think they're fantastic. And I think it's a really supportive professional environment here. There are a lot of jobs, from seismic retrofit to new infrastructure and bridge engineering and things like that to designing high rises. Lots of to designing kind of low-rise residential, if that's what you're interested in. And there's all kinds of firms that do that. Like the bullet says here, the Puget Sound region itself is number 2 in the country in terms of CEEs per 1,000 employed. So, there's a lot of civil engineering opportunities and a lot of structural engineering opportunities, as highlighted by this front page article in the Seattle Times from 2023, a year ago, but it's still very much relevant. And it is bemoaning the lack of civil engineers in the state, the need for civil engineers in the state, and how the lack of those engineers is hindering some of the really giant and important infrastructure projects that are going on in the region. Of course, Seattle is also a great place to forget about work for a while. We are a 3-hour drive from 3 national parks, and they're gorgeous. Mount Rainier National Park, Olympic National Park, and North Cascades National Park. The city itself is fantastic with lots of things to do, lots of restaurants, lots of sports. University has lots of sports, and the city itself is surrounded by water, and it's just really, really pretty. So if you're interested in our program, to be considered for the PhD and thesis programs, we need your applications by December 15th. If you are interested in the professional master's program and you want a decision by March 15th, we require your application before December 15th. If you are interested in the professional master's program, but you are not, but you do not need a decision by March 15th, then we want your application by May 1st. And then we promise to notify you of admission by June 15th. And then the final deadline for domestic professional master's program students on a space available basis is September 1st. But really, if you're interested, you should apply by May 1st if you can. That's it for kind of the scheduled portion of the program, and we can now turn it over. I guess open the floor for questions.
Yeah, thank you so much. I'm gonna go ahead and just before I forget, I'm gonna put the advising email address in the chat so that people have time to save that. In case you have questions that pop up after our session today, feel free to email us. We do meet with prospective students as well, so if you have like a lot of questions or like feel the need to set up a meeting, happy to do that. And then with that, I'll go ahead and open it up to questions. If you want to use the hand raise function, or feel free to type your question in the chat and I can read it off. All right, so Sean, do you want to go ahead?
Hey, you can hear me?
Yep.
Okay. Thank you for the presentation. I was just wondering, basically, could you explain what lab facilities are available for students interested, particularly in structural load testing and full-scale load testing?
Yeah, absolutely. Sorry, I should have had a slide on our facilities. That's
okay.
It's a big draw. I will put in the chat right now a link to the structural engineering facilities. Give me one second to get that in, and there we go. Okay, great. Okay, so facilities here, and then I'll share my screen again, and I can kind of talk through a couple of them for you. Let's see, where's the chat? Where'd you go? There. Okay, great. Excellent. Okay, and then let me just share this. Okay, great. Okay, so we have a few different labs that are associated with structural engineering. I'll kind of talk about all of them. So we have kind of the one closest to what you're talking about, Sean, is the large-scale structural engineering testing lab. We call it the SRL, Structural Research Lab for short. Let's see if I can pop some of these open. That features a 2,400 hip, so 2 million pound universal test machine that we test all kinds of things with. Here, this is a shear test on a big concrete-filled steel tube. We also have a strong wall and strong floor and a series of high-capacity actuators where we've tested things like braced frames, as you're seeing here, and other things. Right now, we're testing slab to column connections. There's a big test going on where they've cast reinforced concrete columns with tributary slabs, and they're looking at the shear strength of slab to column connections. So they're essentially pulling the slab down to get a shear failure of the slab. And that is occupying a large portion of our strong floor as well. So that's kind of the large-scale structural test lab. To go along with that, we have a X-ray computed tomography laboratory. And in there, what we are able to do, it's used by people all over campus, but its structural engineering use is often for components that we have tested in the large-scale structures lab. We're able to take them over to the X-ray tomography machine and actually do some CT scans. It's got really high energy scanners, so we can actually see inside welds. We can see inside, see reinforcing steel inside large sections of concrete. And so what we often do is kind of pull out the failed section of a large-scale test and then scan it in the CT scanner to investigate the failure modes in more detail. And then we also have the Natural Hazards Reconnaissance Facility, the RAPID facility. And this will go to the RAPIDS website. And this is a facility that houses, let me see if I can find a couple projects here. So it houses laser scanners and drones and things like this that are used for reconnaissance following natural disasters. And they do field data collection, so fly drones, use laser scanners, even acquire environmental impact data to study the performance of infrastructure systems and natural hazards. And so they'll go out after hurricanes and earthquakes and things like that. And there's opportunities for graduate students working on research projects to essentially utilize all of those different facilities.
Thank you.
Awesome. That was a really good question. I feel like I don't get that one enough from prospective students. Okay, we have someone else in the chat who's interested in pursuing research-focused master's program, particularly in topics within the University of Washington's research scope, such as performance-based seismic design on steel structures and the study of connections for concrete-filled tube components. And they would be grateful for any recommendations on how to effectively approach professors to inquire about potential research opportunities. So I guess overall question, how do you recommend approaching faculty members, especially when it comes to research?
Yeah, that is challenging, especially if you're not here. I assume you're not at the University of Washington right now. And can't just come knock on an office door, which is definitely the best, the most effective way to do that. We get a lot of email from prospective students. I will say that. I probably have in my inbox every morning between 5 and 10 students from all over the world who want to talk to me about research projects. And to be honest, I can't respond to all of them. And I know my colleagues feel the same way. We just don't have the capacity to respond to all of them. But I do look at just about everyone that comes in. When I look at those, and then make a decision about whether or not I'm going to respond. I typically look at them and I'm looking for kind of like you just wrote here. I'm looking for people who are interested in working in areas that I work in. So, look on people's websites and see what they do and write that in the email. I'm looking for students who are really strong academically. So, make sure you either attach, you don't have to attach a transcript, but attaching a resume with a GPA is really important. If you can connect to other faculty at your institution that we might know and essentially name drop them, say, I work with, or I, took classes with Professor so-and-so who also does research in earthquake engineering, and you probably know them, and that can really, really help to just separate you from again the other emails that we get. And then I will say that we do not make or commit to any offers to any students until that December 15th deadline passes, and then we look at the whole pool of applicants. So just because you've written an email and you may have gotten a response that's really not any kind of commitment. It's just, what you may be encouraged to do is to actually apply, and then we will look at your application along with everyone else who has applied to determine how we're going to make offers. And similarly, when you're writing about within the statement, or within the statement associated with your application, or trying to select people to write letters of recommendation, talking about your research experience is really important. We've had students attach journal papers they've written as undergraduates, or conference papers they've written as undergraduates, things like that. And that is really helpful. And then getting letters of recommendation from people that are well known, that we're likely to know, that is also very helpful. If you can imagine, there's a lot of civil engineering programs out there, and it's hard for us to kind of determine, how they rank relative to each other. But having good letters of recommendation is I think the best way to separate yourself.
Yeah, I guess if I can add on just briefly, the other thing I would say, I did include the link for the faculty sort of web pages and bios in the chat. I always tell students, like you were saying, Jeff, it never hurts to reach out, introduce yourself, make sure it's a personal message and not, like an AI type of message. I've heard those are going around. But yeah, it never hurts to kind of get your name out there, and don't take it personally if the faculty don't respond to you. It's not a reflection on you at all. They're just busy and they get a lot of emails. Great. Any more questions? Give it a couple more minutes.
I do encourage you, though, if you are interested in the research program, to apply. We do look at every applicant. Every applicant is reviewed by 2 faculty, and in order to develop our list of students that we're going to make offers to.
And when you fill out your application, there is a little box that you can check. If you're applying for a research track, you can also check the box that you'd like to be considered for the professional master's program. And because I get this question a lot, if you check that box, it doesn't affect your odds of being accepted into the thesis master's or the PhD program. It's just sort of like after the fact, you will also be considered for that. Great. Anything else you want to add, Jeff?
No, I don't think so. Yeah, I mean, I think like what the standout things, like I said, for our program are really the Seattle area is I would consider it a hotbed for structural engineering. It is really, the firms here are fantastic. They're at the leading edge of structural engineering in the United States. They're involved in code development. They're involved in really fantastic special projects. There's just a lot of really good things that are going on within structural engineering in Seattle.
Great, yeah, and it looks like we have one more quick question in the chat. Does UW or CEE offer application fee waivers for international students? I can answer that one. Unfortunately, our department does not offer fee waivers. All right. Well, if anyone has other questions, if you think of them later, like I said, feel free to email the CEG info account. Sean, did you have one last question?
Yes, just one last question. You mentioned for people interested in the PhD, like if you had any questions, you could stay after or something.
Oh, sure. Yeah.
Yeah.
This can be after.
Okay, sure. Yeah. So I suppose like if I'm somebody who's interested in doing both, but doesn't know necessarily like if I'm going to fully go into one track or like if I want to kind of see the waters,
Yep.
do you think that it's best to apply for the research-based masters, and then from there decide whether or not to move on to a PhD program?
Yeah, I would encourage if you are unsure about the PhD kind of at the beginning, then you should not apply to the PhD program directly. Really, we want people applying to the PhD program who are kind of, committed to starting that program right from go. And if you're instead, like you're maybe describing, and we have a lot of students that fit that, they're like, well, I'd like to think about research and I could see myself doing a PhD, but I really want to see if I can do research and write a thesis and do all the things that have to go along with that first, then I would say apply for the thesis-based master's program.
Okay, thank you.
Yeah. I mean, I was that way. So,
How did you figure it out, I guess? I don't know if that's something you just get with experience.
I really enjoyed the research, honestly. You kind of get a little bug, right? It's like,
Yeah.
oh, this is like really interesting problem solving, and problem solving for problems where, there's not an answer, then that's the reason you're doing the work. And so that's, that is, I think, interesting. And yeah, that's what really hooked me.
Yeah.
And then teaching too. I really like teaching, and I had a great advisor, and yeah, and we did some really interesting stuff.
Nice.
Yeah, but it started just like that. It started, started in the working in the lab on a test and wrote a thesis, and then it was like, oh, well, I guess I could do this. And he was encouraging, and then, that's what it turned into. So,
Okay. Okay. Thank you.
yep.
Awesome. Any last questions from anyone else? Okay, I'm gonna go ahead and stop the recording. Oops.